Alright, so I just wanted to do a little video recording with you all to make sure that we are all reading the HR diagram correctly. Once again, let's just remember that the coolest of stars are going to be over here to the right. So these are going to be our coolest stars. And that will go all the way in this direction to the warmest stars. And our magnitude or brightness is going to be from bottom to top. So the dimmest stars are at the bottom of the diagram, and the brightest stars are at the top of the diagram. If you need to do this to yours to make sure that you understand, then please do that. Also, remember there was a correlation between color and temperature of the star. The cooler stars are going to be on the red, so they're red in color, and then it goes from orange to yellow, pretty much to blue, blue-white, blue-white to blue. Blue is the warmest of all the stars, the coolest, no, the warmest. I'll get it right sooner or later. The warmest, if you've ever seen, have done flame tests or seen different things burn. Red, yellow flames are by far not as hot as a blue flame. They're the hottest flames, just like here we have with our stars. All right, so also our sun, just remember our sun is about a magnitude or a brightness of 1 on the Hertzsprung-Russell diagram, and our sun is a yellow medium-sized star. Also, we noted that these are main sequence stars. They kind of run across diagonally on the whole diagram. So here they are. These are the ones doing hydrogen fusion. So they're basically living stars. And remember we said depending on the size of the star during its life cycle, when it's on the main sequence, that will also determine if it becomes a giant or a supergiant. Our sun will become a giant because it's basically a medium-sized star. It's not very big. But larger stars than ours will become supergiants. And if you remember following the life cycle, a giant like our sun, so as our sun begins to die off, it will expand to a giant, and then it will collapse on itself and become what is known as a white dwarf. And eventually it will become a black dwarf. Black dwarfs aren't on here because they're not just dim, they're dark. You can't see them at all. You only know they exist because of their gravitational forces that they still have. Extremely large stars that were on the main sequence will expand to become supergiants, and these stars will go on to either becoming neutron stars as they die off, or black holes. If they were extremely large in life, they will become black holes when they are totally dead. Those two wouldn't be on here because it goes from dimmest to brightest. It does not go to a blackness, okay? All right, so that's where we're at. Just know that the names do indicate size as well. So a supergiant is going to be larger than a giant, and giants will be larger than main sequence stars. White dwarfs are going to be the smallest of all, and this is the last stage for like a star like our sun. After that, it will be off the diagram as a black dwarf. All right. So one thing that you're frequently asked to do on a diagram like this is compare temperature or brightness of various stars. So my suggestion is when you're doing this, make sure you locate your stars. Let's know what the difference is between Barnard's star as far as temperature goes compared to Sirius. The first thing I'm going to do is I'm going to locate Barnard's star. It's right here, and here's Sirius. So temperature-wise, Barnard's star is cooler, Sirius is hotter. Barnard's star is dimmer, Sirius is brighter. Remember, cooler to to hotter, dimmer to brighter. Okay, that's how this is read. So let's do another one. How about the sun? How does the sun compare to Polaris? Which one is larger? Well, a supergiant is definitely going to be larger than our sun, so Polaris would be larger. Which one is dimmer? Well, the brightest are up here. Polaris is brighter, and our sun is dimmer. Okay. What about temperature-wise? If you look at here, they're both pretty much yellow stars, so both of them would have similar surface temperature and similar color. I think that about sums it up, so just pay attention to how you're reading your HR diagram. It's pretty simple once you get to know it better. It won't be a problem. Just remember, coolest stars are on the right, warmest stars are on the left, dimmest stars at the bottom, brightest stars are at the top, and you should be just fine. Thanks for watching.